This presentation is delivered by the Stanford Center for Professional Development.
All right, C++ plus Java versus Java. It's like a death match. Okay, what's the same? The first thing I really do want to talk about is that there are a lot of things that are the same. And so you are building on a background that's going to serve you well without having to make a lot of adjustments. In some sense, they're almost so similar at times to be a little bit unhelpful in the sense that it's easy to get tripped up because they almost but not quite are exactly the same. There was one unfortunate quarter where I was teaching two classes, one that was being taught in C++ and one that was in Java, and I was just a mess the whole quarter, like constantly in one class using the wrong syntax and vice versa. Luckily, I'm not doing that now, so hopefully I'll have my C++ head on straight the whole quarter. The general syntax, so I'm going to mention these things and I'm going to show you a sample program and we're going to walk through it. But the things like the comment sequence, the /*, the //, right? The use of almost all the punctuation characters, braces, parens, commas, semicolons, is exactly the same, right? That the statement terminator that the semicolon is used for, the commas to separate arguments going into a function call, the way you make variable and parameter declarations, right? Exactly the same, right? No changes there to be aware of. All of the primitive variable types, char, int, double, plus the kind of more esoteric long and float and short and things like that are present in Java are present in C++ and have basically the same semantics. There is one minor adjustment there, which is Java's Boolean type, the true-false variable type, is actually called bool in C++. So you have to type a few less characters on that end. All of the operators that manipulate the basic types, the assignment operator is the equal sign, the equals to compare, not equals to see if they're not equal, the arithmetic plus, the plus equal, multiply equal shorthands, the plus that comes in both pre and post increment, the relational less than or equal to. The logical operators and, or, and not have the same behaviors, they have the same short circuiting, the same precedence table, so all of that, right, is without change. The control structures, so for redirecting control flow and making choices about what code to execute when, the for and while loop mechanisms, the if with the optional else, the switch statement, which you may or may not have seen, but you can definitely look up in the text if you haven't, right? That kind of has like a variant of the if-else that lets you decide based on the value of something which case to move into. The return that's used for the function. Also things like the break and continue, little less known keywords there, or the do while also. Same thing that they operate in Java, they work the same way in C++. So hopefully you feel a little bit like, okay, I'm not totally in a foreign land. Let's look at a complete C++ program. So this one is printed in handout 4, if you want to follow along there, make notes on it as we talk it through. And what I'm going to do here is I'm actually planning on just kind of walking through this almost line by line to kind of just point out some of the things that are different. And then I'm going to move to the compiler and we'll do a little bit of experimentation with developing and writing some code and manipulating something that looks like this to just kind of get some of our bearings about what things are going on. Okay, so first off, just some general structure, right? A C++ program is traditionally written in a text file with the suffix somename.cpp for C++. There's actually some other names that sometimes get used, like .cc or .C, that are also accepted by a lot of compilers. So some text extension, though, that identifies that this file has C++ code, there's a couple variations. We'll use CPP. The program is traditionally, in a simple form, is just one file, just that one CPP file with all of the code that's necessary to be in there. So let's take a look at it. This one starts with a comment, always a good idea, right? Using the /* multi-line comment to identify it. It says, oh, this is average.cpp, and it adds scores and prints their average, right? So just like all the good style habits that you have in Java, hopefully translate quite well to C++ about just explaining to the reader where we're going and what we're doing. The next 3 lines are pound include statements. Pound include is analogous to the Java import. So the C++ compiler is pretty rigid about wanting to see things kind of in the proper order. Before you start using some facility, it wants to know about it. That's really part of kind of the safety of making sure you're using it correctly. So if you plan on drawing something to the screen and doing some graphics, it wants to be sure you're making calls to the graphics functions correctly with the right arguments, the right names, the right arrangements. And so in order to know that, it has to ahead of time have seen that that bit of structure and interface. And so the way this is done in C++ is through these interface or include files. And the pound include mechanism is really fairly primitive. It basically says, look for exactly a file with the name genlib.h and take its contents and kind of dump them right here. The contents of genlib.h and simpio.h are actually, to give you just a little insight, we're going to see them more later, list the operations and the facilities that are available in this particular header that we're trying to include. In this case, the genlib is a 106 specific header that all our programs will include. It gets us set up with some basic foundations. The simpio is our simplified I/O header that adds some features for interacting with the user at the console. The next one down there, right, is include IOStream. IOStream is a C++ standard header. And that helps to point out the difference between why in one place I was using double quotes to name the header file I'm looking for. In one place I'm using angle brackets. That this is a way that's distinguished for what header files are what are called system standard. And it looks for them in a particular place where the standard header files are. Those are always enclosed in the angle brackets. And then in double quotes are local headers that are specific to this project or this environment, right, that are not C++ standard. So whenever you see these double quotes, you'll think it's my own local headers or headers from the CS106 libraries. Anything in angle brackets is a system standard header you'd find everywhere. So it kind of matches like what you do in import, right? You say, I'm going to be using these features from this class. Let me import its features into here so that the compiler knows about them. Next little line I got here is a declaration of a constant. This is the const whose name is numScores. And so it looks a little bit like a variable declaration, right? From this point over, right, you see I have int numScores equals 4, semicolon. Looks a lot like a variable declaration. The const in the front of it is our way of telling the compiler that this particular value, right, once assigned will not change. So it is equivalent to kind of the use of final in the Java language in many ways, to say that. And so this is being declared kind of outside of context. So maybe one point to make here, right, is that C++, right, it derives on more than one way of expressing code in what we call its paradigm. So Java is a completely object-oriented language. Every line of code you wrote went inside a class. It's all about classes. You wrote this class that manipulated the thermometer. You wrote this class that, you know, drew with the turtle or whatever. But there was no code that ever existed outside of a class. It always was. You started off with public class something, and you started writing methods that operated on that class. Maybe they were static or maybe not. And that the way you started code was always to say, start from this class's main to get work done. C++, right, is a hybrid language. It has object-oriented features. It has the ability to define and use classes, and we'll see that quite extensively. But it also inherits the legacy of C, which is pre this whole object-oriented development, where it operates more procedurally, they call it, in the procedural or imperative paradigm, where there are functions that exist at the global level that don't have a context of a class that they operate in. There's not some this that's being received the message and operating. They're just functions that exist outside this, like a little set of things to do that don't live inside a class. And for much of the term, we're going to be doing stuff in a very procedural way, at least in the code we write, and we will use a lot of objects. So we'll actually be mixing and matching a little bit of those paradigms together. So using the procedural paradigm to write a lot of code that then happens to manipulate objects using an object-oriented set of features. So in this case, right, the program here, this is just actually up at the top level, and it's saying this is a global constant that's available anywhere in the file after this declaration. I can use the numScores, which will refer back to this without any further adornment. The next thing underneath that is a prototype. So this is actually a little bit of a novelty, that in Java you are allowed to declare, if you have three methods, A, B, and C, and maybe A calls B and B calls C, you could declare A, B, and C in any order that's convenient for you. You want to put them alphabetically, you want to put them in the order they're called, you want to put them in the order that the kind of top to bottom down or bottom up. It doesn't matter, because the Java compiler kind of looks at everything once and then kind of goes back to get the whole picture. C++ tends to want to look at a file once, kind of top to bottom, and not have any reason to go back and revisit things. It happens that in the main function, which is the one where code starts from, I want to make a call to this getScores and average function. And if I had left this prototype off and I had this code here, when it gets to this line where I'm making that call, the compiler hasn't yet seen anything about get scores and average. It's actually on the next page. And it will complain. It will say, I don't know what this function is. You haven't told me about it. It came out of nowhere. And this prototype is our way of informing the compiler about something that's coming up later. And so the prototype tells about the return type, the name of the function, the type and names of the arguments and the order of them, and then ends with a semicolon. It's just it matches exactly the function header that we'll see on the next page, and it just tells the compiler in advance, here's something that's coming up later in the file, is a function with this name and this signature. So something you didn't have to do in Java, but is a part of the C++ world. There's actually an alternate way I could have done this, which is when I show you the code for get scores and average, if I actually just define them in the other order, I could avoid that separate prototype. And it's a little bit of a matter of personal taste, which way you feel comfortable doing it. So let's look at this guy. So main is special. The actual name, lowercase M-A-N-E, M-A-I-N, whatever. I'm a terrible speller, by the way. Has no arguments, returns an integer type. This is the function in a C++ program where execution starts. There can be exactly one main function with this name and this signature, and it will, when the program kind of gets up and running, the first thing it does is start executing the lines of code that come in this function. So no objects are created or any kind of fancy outer structure the way it might be in Java. It just really just goes here and just starts doing what you told it to do. So main has a special role to play in any program. What this program does is first print something. And this is the C++ syntax for printing things out. Even if you haven't ever seen it, you probably can get a little bit of an idea of what it's trying to do if you just kind of step back from it and squint a little. It looks a little bit like system.out.println. This is what's called the console out, the standard out here that's on the left-hand side. And then these use of the double less than here is what's called the stream insertion operator. So the standard output stream is saying insert into that stream, and then in the double quotes is a string. This program averages. And then it says insert next to that the num scores, which is this constant. It got the value from above, and then another string. And then at the very end, there's this little end L, which is the end line insertion, what's called a stream manipulator. That says at the end of this, put a new line and start any subsequent text on the next line. So in Java, right, that would look like a system.out.println of this program averages plus the num scores plus that using the string concatenation and conversion stuff in Java. It looks a little bit different in C++, but in the end result, right, it's a matter of printing out a bunch of things, numbers and strings intermingled, new lines, nothing too fancy there. Okay. The next line is make an call to that function that we've earlier told it about, we haven't yet seen the code for, that makes a call to get scores and average. It passes the constant num scores and says that's how many scores. It turns out that parameter is used to decide how many iterations to run the loop, requesting values, and then it returns the average of the values entered. And then we take that number, so we stored it in a variable. So this just shows that in C++, right, you can declare variables anywhere, either at the start of a block, in the middle of a block, kind of where they are at, and just like you can in Java. And then we took that value, stored it in this variable, and then used it in the next print statement. And then finally, last thing we have is a return 0. The signature for main in C++ always returns an integer. That integer is not all that useful in most situations. It's intended to be a kind of a return that tells the operating system who invoked the program whether everything completed successfully or not. By default, the value that's used to show successful completion is 0. So unless you have some other reason, it is return 0 that you'll always see at the end there. In reality, if you were to turn something else, you won't see a lot of other differences. You turn -1 or 642. In most contexts, that number is almost ignored. So. But it is there just to kind of make tidy. I'm about to flip to the next part. And this is the decomposed function, right, that main made a call out to, that does the averaging of the scores. Got a little comment on the top, right, that tells a little bit about how it works. Always a good idea to kind of get some documentation in there that's helping the reader get oriented. That same matching of the prototype that was given earlier, same name, same argument, same things, but instead of ending with that semicolon, it goes into the body. So sometimes we'll call these very similar terms, this we'll call the definition or the implementation of a function, and that earlier just introduction of it is called its declaration or its prototype. And they should match, and they're just there to give warning of something coming up later in the file. It initializes a sum to 0. It runs a standard for loop here. Like Java, we tend to count from 0 as computer scientists for kind of a long legacy reason and a little bit of efficiency, where instead of going from 1 to num scores, we actually go from 0 to num scores minus 1. Sure, why not? And then each time through the loop, right, we are prompting the user to give us a score. We're actually reading their score with a getInteger call. And we'll see what getInteger is. getInteger actually is a CS106 function, but it actually retrieves a number that the user types to the console. We add that into the sum, keep going, right? And after we've done the whole thing, at the very end, we're doing a division of the sum by the number of scores to compute the average score that was entered and return that. All right, you've seen some C++ code. Ask a question.
Sorry, did you say why we didn't have inline?
In this case, I didn't have an end line just because I think it makes it nicer for the user. If you say next score and the end line, then you're typing on the line underneath it. And so if you don't put the end line there, it's like you type right next to the question mark. And so it actually, it's just, you know, it's totally an aesthetic thing. And so if I'd put it there, then it would say next score, and then I would be typing underneath it. And instead, I'm typing right next to it, and then I hit the return, and then the next one comes on the next line. Anything else?
When you're passing the integer, is it passed by reference or passed by value?
Yeah. So it turns out it's passed by value, and I will talk about that a little bit later today. But it is, that's a good question, but a little bit advanced. So just take my answer, and then we'll get to that in maybe 20 minutes if anybody else.
So for every main function, we always have to end it with return 0?
Pretty much, right? You can, as I said, you can put return anything, but as sort of good form, return 0 is a way of saying I successfully completed my job and I'm done. There's Carmel's on the line. What can I do for you?
Could you use a void return type for the main?
In C++, no. So in C, actually, it's a little more lenient about that, and it will allow that. In C++, it wants an int return type. So just part of the thing. Now I have to decide if I can get this to you without hurting anyone. Oh, so you, the Jessa Lee is the student to go thank for the caramels. All right, so let me just do a little coding with you guys, just to play around with this and show you the compiler. I like to do a little bit of this in real time because I think it's really easy for me. I talk very fast, you might have noticed, and when I get going on something, it's really easy for me to just put up a lot of code on a slide and say, here it is, it's all fully formed. And the reality is, of course, is when you're writing your programs yourself, yeah, it's not going to come to you fully formed on a slide all ready to go. And you're going to have to kind of figure out, well, how do you step through making this stuff work? So I'm going to actually do a little bit of development of a program that looked very similar to the one I just wrote, but I'm going to play around with it a little bit to just get at some of the things that are different about C++ and kind of how the tools work and things like that. So this is basically what an empty project kind of starts me off with is I've got, you know, the include for the genlib that I'll always have, my int main that returns 0, and sort of nothing else doing. So I'm going to sit down, I'm going to start typing. I'm going to say welcome, and get that going. And then I'm going to move to, let's just do this. We'll play with this for a second here. So some things that I can do. I could say welcome a lot of times. Well, that wasn't really so hot there. There's a little I missing. How about that? You guys can help me when I fail to type correctly. And I say welcome a lot of times. Let's go see this, make sure this works. Okay. Oh, look at that. It doesn't like what I did. Let's see what it has to say. It says cout was not declared in the scope. Endl was not declared in the scope. So this is an error message you're going to see a lot of times in various other symbol names that'll show up there, which is the C++ compiler's way of saying to you, I don't read your mind. You use cout, you used endl. These things come from somewhere, but they're not known to me until you make them known to me. And the way I make those known is that those are part of the standard I/O stream, which is the input-output streams facility for the C++ language. And once I tell it about those things, it's going to be much happier. And it's going to say welcome to me a lot of times. And in fact, I could say this, let's say something better, 106B rocks. And then I'll do this. I'll say, how awesome equals getInteger. And I will, so it might help if I move this up a little bit so we can see how awesome, how much do you love 106B? So here I won't use my endl, so we'll see how the prompt comes out. I'm going to get an integer from them, and then I'm going to use that to write how awesome that many times. Okay, so what is it not like about that? Oh yeah, again, it says get integer, not declared in the scope. This is going to be the bane of our existence today, which is like, yeah, remembering that there are headers out there that have features that we're going to be using, and getting familiar with the ones that we're going to need. There are probably about, 10 total that we'll use again and again and again, and we have to kind of get our bearings about which ones are where. The documentation for all of our CS106 headers is available on the website, kind of in a nice HTMLized version, and the ones from the standard libraries are detailed in the book, kind of on little sidebars on the pages in Chapter 3. So once I get my, actually, how much do you love 106B? I could say, well, I love it 2 times. Okay. I say, no, really, I love it like 1,900. And so, all right, so there you go. 10,000 times later, or if you're not convinced now, I don't know what will convince you. We've seen that. So we've seen a little bit of program, right? We're writing a little bit of things. We're seeing some stuff. It's moving around. Let's see if we can make that averaging thing work for us. Okay, I'll go back to just having to say welcome. Which reminds me, just to note that that's what the endl was doing for me there, which is now the prompt is actually kind of waiting at the end of that line. If I had the endl, it'd actually be waiting on the next line. So, okay. We're done with that. Whoops. Okay. Let me just put kind of a bogus message here, and then I'm going to say double average equals get scores and average. And then let's go ahead and, well, I'm going to blow off the constant for a little bit, just because I'm going to be mucking with it anyway, and I'm not going to use that constant for very long, so I'm not going to worry about it yet. Okay, I'll put my prototype up here. So it knows what I'm talking about, and then I'm going to print out average is average. Okay, so I got a little bit of structure there, and I can even, I'll go to here, copy and paste, really good idea. Like once I've written the function header once, I don't really want to make a mistake. And I can, something that's kind of interesting to know is that, you can always write code that actually doesn't really do what you want to start with, but that kind of lets you test some of the other pieces around it. So in this case, right, I haven't finished fleshing out what get scores and average is, but I can write code around it that says, well, it passes in this number and it does some stuff, right? And right now it just returns 0. It's totally bogus. It's not, solving any of my problems, but it does allow me to test some other part of the code, in this case the main that called it and printed the result, to make sure that connection and kind of other parts are working before I go on to kind of work on this part in isolation. One of the things I'll try to show you whenever I'm doing code is to try to give you a little bit of the insight into how I approach thinking about the code, because I do think that one of the things that really distinguishes somebody who works effectively and productively from someone who spends a lot more time doing it is often just strategies and tactics for how you kind of attack your problem. So I'm hoping that along the way I can kind of share a little bit of the insights that I use to keep myself making forward progress there. So I am going to put in that for loop that I'm looking for, I being less than. I'm really not this bad of a typist in real life, but it's easy to. Okay. So the use of the braces here, right, is what's defining the block structure. So without the open curly brace, close curly brace, right, the for loop and the if and the other statements only grab that next line as being part of the indented body of the for loop. I'm going to go ahead with my next idea. I'm going to put that into sum, and then I'm going to do some things that seem kind of bogus, but we're going to get there. So I'm going to make some mistakes. You're going to watch me make some mistakes. Some of them I'll make on purpose. Some of them I'll actually be making accidentally. We'll see which ones I'm better at finding. So I have my get scores and average. It asks them for the scores. It adds it into the integer, and then doesn't return anything. So first, let's see how the compiler feels about that. So the first thing you'll notice is that compiled. That might alarm you just a little bit, because if you go back here and you look at this code, it certainly seems wrong. Right? Anybody want to help me with at least one of the things that's wrong with it? It doesn't return anything, right? Like, wow, that seems a little shocking, right? It's like, it doesn't return anything at all. Well, what is it actually going to then produce? What else is it doing that's a little bit bogus? Sum is not initialized, right? So these are two examples of errors that Java doesn't let you get away with. You may very well remember from having typed in some code like this in Java, that it will complain. If you have a variable and you declare it and you don't initialize it and you start using it, the compiler says, not happening. You need to go back there and give that guy an initial value before you start reading it. Similarly, you fall off the end of a function that said it was going to return a double, you better return a double, right? And every code path, in fact, needs to return a double. You can't kind of bail out early in some cases and leave it fall off the end in others. That it considers both of those, right? Big enough errors that it won't let you get away with them. C++ compilers are a little bit more lax. It's crack mom, I told you. It's like, well, if you don't want to initialize that, go ahead. What value does it have then? That's a caramel earning moment there. Exactly what was in memory before. It doesn't make it 0. It doesn't make it empty. It doesn't do anything nice or clever or helpful. It's like whatever kind of contents were lying around in that particular location, now it's new initial value. So the result will be that we could get some pretty strange results from this. So if I run this thing right now, let's just see. I type in some numbers. I type in, oh, somebody got a 9, somebody got a 67, somebody got an 87. Type in a bunch of numbers, and the average is 0, right? Well, that was kind of interesting. 0 kind of seems like it had some rhyme or reason to it, but in fact, actually, there's really no guarantee I could run it again, and I might get very different numbers. Let me make it so I don't have to type in so many numbers because I'm lazy. And I put in 5, 6, 7, 8. I got 0 the second time. Well, see, good luck for me. Let's go in and start fixing some of this stuff. So the thing to note is that the compiler isn't nearly as aggressive about being on your case about things, so it does require a little bit more monitoring on some of these things, that seeing this result and then kind of going back and kind of figuring out how I got into this situation. So let me get that guy an initial value, and then let me put a return down here. And then we'll see if I like how this works any better. So I put in 5, I put in 6, I put in 7, I put in 6, and the average is 6. That looks good, right? That sort of makes sense to me that the 5 and the 7 kind of cancel each other out. But if I do a little bit more deep testing, where maybe I put in some numbers like 5, 6, 5, 6, right? My average is 5. And in this case, I would think that I would be getting something like 5.5, right in the middle of the average. I go back here and I take a look at what I did, right? And I took sum and I divided it by num scores. What have I failed to do? Cast that thing to get it out of there. So the default, this is the same in Java as it is in C++, is that if you are combining two operands in an arithmetic expression, if they are of mixed type, one is double and one is int, it promotes to the richer type. So if that one of those was a double, it would convert the other one to a double and do the calculation in double space. But as it is, sum is an integer, num scores is an integer, it's doing integer division. Integer division has truncation built into it, so if I divide 10 by 3, I get 3, and that remaining 1/3 is just thrown away. Even though the result is double, that sort of happens after the fact. Like it does the calculation integer space, the 10 divided by 3. It gets the 3 integer result, and then it says, oh, I have an integer here. I need to convert it to a double on my way out, and it takes that and turns it into 3.0. So it doesn't recover that truncated part that got thrown away. If I really want to get a real double result, I got to make one of those a double to force the calculation into the double space. The mechanism in C++ is a little bit different than it is in Java. In fact, the Java mechanism does work, but the preferred form in C++ looks a little bit like this, where you take the name of the type you're trying to convert it to. It looks a little bit like you're making a function call, passing sum to a function that will change it into a double. And so by doing this, right, I now have one of them being double, the int on the other side gets promoted. So if I do my 5656, right, that truncated part is now part of that calculation and preserved and pulled out and printed. All right. Okay on that? Let me change this a little bit to something else. Right now, it assumes that there's a fixed number of scores that you want to do. Maybe what I have is a big stack of exam papers, and I don't actually know how many are in the pile, and I don't actually want to count them ahead of time. I just want to actually just keep entering scores until I get to the bottom of the pile. So I'm going to change this loop to allow me to enter numbers until I say I'm done. Okay, so let's take a look at what that's going to look like. I'm going to get the value here. So I'm going to change my code a little bit. And then if the value is the sentinel, then I don't want to include it in the sum, and otherwise I do. So maybe we'll do this. We'll say if the value doesn't equal the sentinel, then sum kind of, adds it into there. But I also need to make this thing stop. And so I'm going to have to rearrange my loop a little bit here, because if you think about what I'm going to try to do, I'm going to prompt and get a value, and then either add it in the sum or quit. And then I'm going to prompt and get a value and add it in the sum or either quit. So I have a loop where I need to kind of rearrange my notion a little bit here. And one way I could do this is something like this. I could say this: well, while value does not equal sentinel, then add it into the sum. So I'm going to kind of change my code around. Just sort of watch carefully as I reorganize it. So if the value is not equal the sentinel, then I'm going to add it into the sum, and then I'm going to get the next, and overwrite the previous value. So watch this. Value is this, and I'll go up here and I'll say int value. Okay, so I kind of inverted that loop that was there a little bit. So it says, okay, well, while the value is not the sentinel, add it into the sum, and then get the next value and come back around. The problem with this code as it stands is there's something a little bit wrong about value, right? It's not initialized, right? So I need to initialize it to something. It's like, well, what do I need to initialize it to? Yeah, I need to what the user wants. So in fact, this little piece of code that's down here kind of needs to come up and be repeated up here, right? I need to get a value from them, right? And then go into the, if it wasn't a sentinel, add it and get the next one. This is what's called a classic loop and a half construction, where there's a little bit of things I need to do, and then I need to do some test and then decide whether to go on with that iteration. And as it is, there's kind of a little bit of a half of the loop that kind of starts up. They call it sometimes priming the loop, getting things ready to come into it. And that's a little bit unseemly. There's something about that's a little bothersome, even though it's a very small piece of code. 2 lines of code is not going to rock the world. But I do want to try to get us into the habit of thinking, if we can combine that code and unify it, that's better. It's better than repeating it. Repeating it means that if I ever change something about it, I have to change it in 2 places, that there's an opportunity for error to creep in, that I can avoid if I can get it to where there's really just one and only one version of the truth. So I'm going to change this to, is going to use the break statement, which you may have had a little experience with, which is I'm going to run a while true loop, which looks like it's going to run forever. I'm going to prompt get the value, and if the value equals the sentinel, then I'm going to use break. And break immediately exits the loop here without completing the bottom of this loop iteration, and causes it to move on to the statements after the loop. So by doing it this way, I now have one prompt, right, then a check, and based on that check, I either kind of finish this iteration and keep coming around, or I immediately break out saying that was the clue that we're done with this. You could. I would say that it's a little bit of an advanced question, but it turns out that the do while loop is not really that much cleaner in the end, and because you still have to do the prompt and test and try to decide when to add it in. And do while loops are just so unusual that they cause everybody to slow down a little bit when you read them. So if you can actually kind of write it using a more ordinary loop construct, there is some advantage to that. So I got this guy together here, and then maybe I should actually tell the user, this might be a good thing to say, tell them what the sentinel is. Oops, and I have to type better than I do. If done. Okay. Whoops. And what does like now? Oh yeah, well we better count those number of scores. How about we do that? Num scores equals 0. And then each time we get one, we increment. And so 4, oh that's right, I'm using 4 as my sentinel. Well that's good. 5, 6, and I say 4, then I should average the 5 and the 6. So let's go back, we'll change our call to maybe use a more ordinary value like -1. And then type in 5, 6, 7, 8, 9, and then I can type -1, and the average of those is 7. All right, not bad. All right. So just a little bit, rearranging, getting used to this, kind of seeing this code. Should kind of seem very, very familiar in a lot of ways, but just a little bit of some details, right, that need to be different. I'm going to show you one other little C++ism while I'm here, because it's something that comes up in the standard libraries, and it's worth knowing, is that there's some minor conveniences in the way that C++ provides certain facilities that are not conceptually a big deal, but you do need to know about them because you're going to encounter them in various interfaces. And one is the notion of a default argument. That in the prototype for a function, there at times, and this is no longer num scores, I should really be more clear about this, that's the sentinel now, that there are arguments to a function where it's almost 90 or some very large percentage of the time always going to want to be a certain value, but you still want to leave it open for the user to specify a different value in the cases where they don't want to use that standard value. And so one way of doing that in C++ is to write your function using a default argument where I say int sentinel and I said equals -1. And that is providing for if somebody makes a call to get scores and average passing an argument, it's used instead. If they pass nothing, so they just have open paren, close paren, and they don't give a value for that argument, then the assumption is to use that default. And that means that most people who are making calls to get scores and average, right, can just drop this number and get the behavior of using -1 as the sentinel. But in the case where for one reason or another -1 was one of the valid values that you could potentially enter, you could pick a different one, right, -75 or 0 or whatever it is that you want to use instead by overriding that default argument. We'll see that in the libraries. It's interesting to know the mechanism of it is really quite simple. It's just a convenience, right, for providing for. You can actually have more than one default argument, subsequent arguments right over there. The idea is that you can only leave off when you're making the call kind of the last most argument, and then from there other ones, because it has to kind of figure out how to match them up. So it matches the arguments left to right, and as soon as it runs out of arguments, it assumes everything from there has to be used its default argument for it to match that call. So it allows for, you could have 3 arguments of which you could specify 2 or 1 or 3 if they all had defaults, if you needed that. It's not that common, but it does kind of come up. All right, a little bit of that. Let me go back to my slides a little bit and just tell you about a couple other little mechanisms of, whoops, that's not where I want to be, of some C++ features that are new to us that we want to know a little bit about. There are 2 types of user-defined types that are very simple to get your head around and just want to know what the syntax for them is and what they do. Is the enumerated type or the enumeration, where at the top of your program, so up there where I was defining constants and doing pound includes, this is where we put kind of information for the compiler that is of use across the entire program. This is also where we would put new user-defined types. In this case, I want to define a type direction t, which can take on one of the 4 values, north, south, east, west. And that whole package up there, that enum, direction t, north, south, east, west, is the way of defining the new type. You're saying direction t now comes into the space as a name that can be used for variables, parameters, return types. Any place you could have used int, you can start using direction t. And it has the expectation that variables that are declarative direction t will be holding one of those 4 values. And it's like north, south, east, and west got defined as constants, and they are by default assigned the values actually 0, 1, 2, 3, just in order unless you do anything special. And then you can use them. You can do things on enums that are very integer-like. You can assign them, you can compare them, you can actually use less than and greater than. You can add them. They're things that they are kind of largely implemented underneath the scenes as just numeric types, but they're just a nice convenience for making it clear that this thing isn't just any old ordinary integer. It's specifically it should be kept into this constrained range and mean something a little different. So it's just a nicety. Does not have a lot of heavyweight features associated with it, but kind of a nice way of documenting that something is this kind of setup. This one, the record or the struct type, much more broadly useful. Just an aggregate, right, which you can take a set of fields that of same or different type, give them names, and kind of aggregate them together. You can say, here is a student record, and the student has a name and a dorm room and a phone number and a transcript and all these things. Aggregate it together into a new structure type. So in this case, the point t structure type. And so like this is the kind of thing you put up at the top of your code that says, here's what's in a point t, the field names and their types. And a little point of noteworthy error producing is that there really does have to be a semicolon at the end of this. Similarly, there has to be a semicolon at the end of the enum declaration for direction t. If you forget to do that, there's a kind of a cascade of errors out of that are really a little bit mystical the first time you see them. You learn to actually identify this quickly later on, but it ends that declaration and then allows the compiler to move on to the next thing, not kind of assuming you're still doing some more work with this. Once you have this type declared, you can make variables, return types, parameters, all that stuff, and then the access to the members within the fields within a struct looks like access to an object did in Java, where you have the variable name on the left, and then a dot, and then on the right, the name of the field you're accessing, setting, reading. You can do things like p equals q, which does kind of a full assignment of one struct onto another, so it copies all the fields over from one to the other. So something simple, right, that but does kind of have a lot of usefulness, right? Just it makes a lot of sense when you have a program, right, and you do group things together. Here's all the information about, this part of my data structure, a student, a class, a dorm, all the information being aggregated together into one unit is actually a nice way to keep kind of your data organized. Yeah?
Before I didn't understand exactly how to third line to the end, point t, how much q?
So it's just declaring 2 point t variables, right? One is p, one is in q, right? And then I'm saying, oh, p dot x, so I'm setting the x field of the p variables to be 0. At this point, the p dot y field is nonsense, just garbage. And then I said p equals q, which basically says take the nonsense that's in q and overwrite it onto p and make p be as nonsensical as q is in terms of its contents. Not very useful code. And then the last thing I'm going to show you today is just to talk a little bit about parameter passing. This is going to come up kind of again and again, but this is just kind of a quick first mention of these things. Someone had asked earlier, well, what is the parameter passing mechanism that's in play? The default parameter passing mechanism is what's called pass by value, or it basically to say it copies. That if I have a function here, binky, int x and y, that in the body of it, it tries to do something like double the value of binky and reset y to 0, that when I make a call to binky, and I had a set to 4 and b to 20, that when I made the call to binky, the pass by value really means that the x and y parameters of binky are copies of a and b. They are distinct, right? They are new integer variables, new space, new storage, and they got their initial values by taking the current values of a and b and copying them, but changes to x and y affect binky's context only. And so that 4 that came in here and got doubled to 8, that y that got set to 0, are live here, but when binky exits and we get back to main, a and b still are 4 and 20. So it just did full copies of all and this is true for all types of structs and enums and ints and cars and all that. It's copying the data, operating on a copy. In most situations, that's actually fairly appropriate, right? You tend to be passing information in so it can do some manipulations. In the situation where you really want to be passing in and having changes be permanent to it, change the values, there is an alternate declaration where you add an ampersand to the type. So instead of being an int, it's an int ampersand. And that changes this parameter from being a pass by value to a pass by reference or a reference parameter. In such a case, right, when I make a call to binky, this first argument will not be a copy. The second argument is still a copy because I haven't changed anything about it. But when I say binky of a and b, what the binky function is actually getting in that first argument is not a copy of the value 4. It's getting a reference back to the original a. And then for the y parameter, it's getting a copy of 20. So when it makes this change over here of trying to take x and double its value, it really did reach back out and change a. And so after this, right, a would be 8, b would still be 20. So it allows for you to pass some data in, have it be manipulated and changed, so updated, adjusted, and whatnot, and then come back out and see those changes. That is, for certain situations, very useful. This mechanism doesn't exist in Java, right? There's not a pass by reference mechanism, so this is likely to seem a little bit bizarre at first. We will see this a lot, so this is maybe just our first introduction to this. We're going to come back to this more and more. One thing I will note is that the primary purpose of this is to allow you to kind of change some data, pass it in, have it be changed, but it also gets used in a lot of situations just for efficiency reasons, where if you have a large piece of data you're passing in, a big database, that to copy it could be expensive, and especially for this larger things, right? That copying just so you can hand it off to a function to print it would be unnecessary, and so by using the reference parameter in those situations, you're actually just allowing it to avoid that copy overhead and still get access to the data. So sometimes you'll see it used both for changing as well as efficiency. Okay. I'm not going to show my last slide, but that's what we're going to be talking about on Monday. We'll talk about libraries. So looking at Chapter 3 is the place to go in the reader. I'm going to be walking over to Termin momentarily, and I would love to have somebody come and hang out with me. Otherwise, have a good weekend. You have nothing to do for me. Enjoy it. It's the last weekend in which you will not be my slave.